Hey Zainab, I got your questions for certain problems out of Monday's problem set. Based on the numbers, I think it might have been Tuesday's. So I'm going to go ahead and do that, but if this isn't the right set, just let me know. All right, so number one said a particle starts at rest at the point 2, 0 and moves along the x-axis with a constant positive acceleration for time t greater than or equal to 0. Which of the following could be the graph of the distance s of t of the particle from the origin as a function of time? All right, so two things to notice on this one. One, they give you an ordered pair. The ordered pair is technically an XY ordered pair, which I think is a little confusing in this problem. All right, and then they tell you that the graphs are actually t comma s of t. All right, so when they talk about 2 units away, it starts 2 units away from the origin, from rest. That means that it's starting at an s of t value of 2. So we know we have the point 0, 2 on the graph that we're looking at here. All right, so right there I can get rid of that one and that one. The other three are still in play. All right, now it goes on and it says with a constant positive acceleration for time t greater than or equal to 0. Now, if the acceleration is positive, that means s double prime is positive, which means that we're concave up. All right, so of the remaining graphs, the only one that's concave up is this one. All right, now the most common mistake would have been to choose C, all right, because that does meet the concave up, and all that happened there is you kind of misunderstood how they were doing the ordered pairs, which I agree is confusing in this one. So they gave you 2, 0 as an XY ordered pair, but then they came back and they're talking about a graph that is time versus distance away from the origin on the x-axis. All right, so I hope that helps with number one. If we go to number 4, all right, number 4 says calculator is okay, so we'll probably need to use it here. So it says the velocity in feet per second of a particle moving along the x-axis is given by the function v of t. All right, what is the velocity? What is the average velocity of the particle from t equals 0 to t equals 3? All right, so we're given velocity and we want average velocity. So we're going to do 1 over b minus a, so 3 minus 0, times the integral from 0 to 3 of e to the t plus t e to the t dt. Now, since this is calculator active, we're definitely going to lean on the calculator here. All right, so I'm going to go ahead and let me just get that shrunk down just a little bit there. I'm going to clear out where I'm at. All right, back to my home screen. I've got 1 divided by 3, all right, times the integral, so math number 9, all right, from 0 to 3. All right, now I'm just going to type the function in here because it wasn't a like free response item where I'd be putting this into y equals already. So I'm just going to type it in. So e to the x plus x e to the x, and we'll say dx here. All right, so this is the function, and we're finding the average value of that function, which is velocity, so that would give us the average velocity. If I go ahead and hit enter, all right, we've got 20.085, and it rounded up there, so we're looking at 20.086, and we'll just double check. Yeah, we're 0.855, so that would round up. All right, so that would be the approach for number 4. All right, so number 6, this one's a no calculator problem. It says a particle moves along the x-axis so that at time t greater than or equal to 0, its position is given by x of t equals that function. At what time t is the particle at rest? So a particle's at rest when the velocity equals 0. So I'm going to find x prime of t, because that would give me the velocity. So that would be 6t squared minus 42t plus 72. All right, now everything's divisible by 6. So I'm going to go ahead and factor a 6 out of that. I'm left with t squared minus 7t plus, and 62 goes into there 12 times, so 12. All right, that gives me a 6 times t minus 3 times t minus 4, all right, for x prime of t. Now, that means there's 2 spots based on this equation, t equals 3 and t equals 4, where we're stationary. So what I'm going to look back to is I'm going to look back to and make sure there's not any restrictions on the domain. and it said for t greater than or equal to 0. All right, so both of those values are greater than or equal to 0. So we have two spots where this is at rest, and that is at time 3 and time 4. All right, so E would be the correct answer on that one.